Enzymatic kits have a lot of uses in various industries, including the wine industry. So they're typically used for measuring things such as glucose, fructose and malic acid in our case. There's a number of suppliers. This is a typical one, and you can see it comes in a box and there's a number of reagents there. Each of the reagents is numbered, so I'm going to go through the malic acid enzyme kit today, and we've written the number of the 5 reagents on the tops of the bottles. Now the first thing you must do when you come to set up the assay is to check that the spectrophotometer is set to the right wavelength. For the malic acid enzyme assay, the wavelength needs to be set to 340 nanometers. So the first thing we're going to do is to zero the spectrophotometer with an air blank. Now the cuvettes that you've got are like so, and you'll notice that one side has some lines on it. That's the side that you hold. The other side is clear. You mustn't put your fingers on that side because that's where the light is going to go through the clear side. So if there's any dirt or muck on that, that will affect your reading. So we open the spectrophotometer, and then we place the cuvette in the light path. And the light path is going this way. Like so. We close the lid, we wait a few seconds, and then we zero the spectrophotometer. And again we wait a few more seconds and the absorbance should come up as 0. Okay, so we're now ready to commence the assay. The first thing you should do is to have 3 cuvettes lined up, because there are 3 things that we're going to assay. We've got the blank, we've got the standard, and we've got our wine sample. Now many students actually mix up the standard and the wine sample. Please be clear in your minds that the first cuvette has no wine in it, no standard. The second one has the standard that comes with the kit, so a known amount of malic acid, and the third one is your unknown, your wine. So we'll place these on the bench and we'll commence with the assay. And if you read the instructions in your lab manual, you'll find that the first reagent we're going to add is the buffer. And we're going to add 1 ml of buffer to each of these 3 cuvettes. Now because each cuvette's containing the same reagent and doesn't have anything in it yet, I can use the one tip for all 3 cuvettes. So I've set my pipette to 1000 microlitres, or 1 ml. And prior to commencing this assay, you should have viewed the video on the correct handling of pipettes. Okay, so this is my reagent 1, it's a buffer. It's always a good idea to give the reagents a little bit of a mix prior to pipetting them. And we're going to take 1 ml of buffer out of the bottle labelled reagent 1. There's 1 ml, and you can take the cuvette out of the rack, holding it by the rough edge, and then gently pipette the 1 ml into the cuvette. And remember to go down to the second stop to make sure the full volume is ejected from the pipette. So we'll repeat that with cuvette 2. And then cuvette 3. Now we've finished with the buffer, so we have to eject the tip into a waste beaker. Right, that's finished. The next reagent we're going to add is water. Now if you don't have a beaker of water, you can use one of these wash bottles, that's fine. And you'll notice in your prac manual that the blank has 1 ml of water added to it, whereas the standard and the samples only have 0.9 of a ml or 900 microlitres. And that is because we're going to add our sample and our reagents to those ones, and the volume in each cuvette, in each assay, has to be the same. In this case it's 3 ml. So into our blank I will pipette 1,000 microlitres of distilled water, and placing the tip of the pipette next to the edge of the cuvette is probably the best way. And then for the sample and the standard, we're going to pipette 900 microlitres or 0.9 of a ml. Now the next reagent we're going to add is our NAD, or reagent 2. That's the cofactor for the enzyme, nicotinamide adenine dinucleotide. And as you go through your studies here, you will learn in later subjects the importance of this cofactor in various metabolic pathways. So now we're going to pipette 200 microlitres, 0.2 of a ml. So I'm now using the yellow pipette with the yellow tip, and this is the 200 microlitre one. Okay, so the same sort of principle. And we're putting 200 microlitres into each of the 3 cuvettes. You'll notice that I'm not changing the tip in between cuvettes. Now with this one you can see I've got an air bubble there, so I can't use that, okay? That's when things go wrong, so just check what you're doing. If you get an air bubble like that, don't use that, the volume will be incorrect. Okay, no air bubbles now. We then go to reagent 3, which is one of our enzymes, got. And you'll see for reagent 3, we're pipetting quite a small volume, 10 microlitres. So now we go to the 20 microlitre pipette, but again with the yellow tip. And I'll change the volume to 10 microlitres. The line there is the decimal point. Okay, so it's 10.00, if you like, is what you need to pipette. That's 10 microlitres. Again, we give this a bit of a mix. Now, 10 microliters is very small. Now, for that reason, I feel more confident actually with this one, not pipetting it down the side of the cuvette, but actually putting it directly into the volume of buffer and water that's already in there and ejecting it. And then giving it a bit of a stir. Now, because I've done that, I'll have to use a new pipette tip. Right? So we do that to all three. And now we're ready to add our standard or our sample. So remember, cuvette 1 contains our black, so that gets nothing. Okay, cuvette 1 gets nothing. Cuvette 2 gets our standard, which is this one here, which actually I don't think is numbered in the kit. And our cuvette 3 gets our wine sample. So we've got a white wine sample here today. So we're pipetting 100 microliters of the standard firstly to cuvette number 2. Again, it's a small volume, we give it a bit of a mix. So this standard contains a known amount of malic acid, and from this we can then calculate how much malic acid we have in our wine sample. So there we go, 100 microliters, which is going into cuvette 2. Again, I mix the contents of the cuvette with the pipette tip. Other people cover the cuvette and mix it with paraffin. The method I prefer is to use the tip, making sure that you don't have any bubbles introduced to the cuvette. So we then take our wine sample and add 100 microliters of this to cuvette 3. Now once we do that, we leave the cuvettes for approximately 3 minutes and then we will read the absorbance. So we're ready to read our cuvettes. We've waited 3 minutes. So just to recap, 2 sides to the cuvette. The clear side is where the light path goes through the cuvette. Put it in, and then it's important that you just wait a few seconds until the absorbance is stabilised. So this is our blank, and we can see we've got an absorbance of 0.211 there at 340 nanometres, and so we write that down in our notebook. We then read our standard, which is cuvette 2. And we write down that figure in our notebook. And then read cuvette 3. we're now ready to add the last reagent, which is the Malic dehydrogenase enzyme, or MDH. So I'm now going to add to each cuvette 10 microliters of reagent 4, or the MDH enzyme. So again, this is a very small volume. So we'll use the same principle as I did with the GOT enzyme, and we're adding the MDH to all 3 cuvettes. When you mix the cuvette, it's very important you don't have air bubbles present, because that will affect your reading or alter the light path going through your sample. And for this last step, we're going to leave the 3 cuvettes on the bench for 10 minutes and then read the absorbance again. 10 minutes, and now we're ready to do our final absorbance reading. So same procedure as with the first reading. We put our blank in. There you can see the absorbance. Don't worry greatly if that 3rd digit fluctuates, that's normal. So that's the blank. The standard. And then finally, our wine sample. And this is where we have a problem, because you can't read an absorbance of greater than 1. So in a situation like this, you then have to take your wine sample and dilute it. And given that we've got an absorbance there of in excess of 3, I would probably dilute this wine sample at least 1 in 10. It does mean that you'll have to do the assay again, but now with the diluted wine sample. This often happens, and you won't know until you've run through the assay and measured your sample. Okay, so we've diluted the wine sample 1 in 10, and we've redone the assay, and I'm just going to read the wine sample now. This is the diluted wine sample to get the absorbance, our A1 absorbance for the diluted sample. So as before, we'll write that number down. And then I'm going to add the MDH, the Malic dehydrogenase enzyme, to this one. And then we will leave the cuvette on the bench for 10 minutes again. And if in doubt, always read the label of the bottle. Not a bad thing to do. about 10 minutes. Okay, we've waited our 10 minutes, so now we're going to read our diluted wine sample. And now you can see the absorbance is less than 1, 0.676, and that is acceptable. So we will use that in our calculations. So the final thing for you to do is to take the data that you've been given and to do the calculations as directed in your prac manual.